The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCam. We'll be doing SolidCam live for the 30 minutes free session we're doing today. And just so you know, this session is ready to go, I think, until the 15th, like we mentioned in the last video. And if it goes past that, well, it's user input. If you guys say you want more, let us know and we'll do more. But with me, as always, one man, one machine, all SolidCam, Kevin Rankel.
Well, that's a hell of an intro. Hey guys, well, thanks for coming to the class.
I was telling Kevin, nobody's telling me how to do an intro, so I thought I would at least intro him with something cool. So hopefully every day I'll come up with something. And if you guys know the reference in the questions panel, tell me if you know what that reference is from, because I'm interested to see if you get my my little quirky humor. Okay, great. So today we'll finish up with some of the questions that were lingering from last week. And one of them was going from a 3-axis machine to a 5-axis machine. So how do you basically do that? Well, really simply, it's a change of the post. But changing the post is the one thing that if you do, you're basically restarting the whole file. You want to only do one cam part per post. So what you could do with that is, let's say you did this part on a 3-axis machine. And now you want to put it on the 5-axis machine, but you want to save all the work you did in 3-axis. Well, first, we'll right-click on cam part. We'll do a save as. And the save as basically is going to save an exact copy of this file. So all the same post will be pulled up, the same tool paths, same tool table. But when we save this, it's a copy, basically. So let's just call this one -5x. So this is the one that we're going to put on the 5-axis machine. So this will close this original one. It's working its way on it, but it should be closing the original one and opening it as, in this case, HOS or HSS stock definition -5x. We'll see that on the top of the screen. But this is the same file, essentially, just renamed. So the same CAD cam part model reference, the same toolpath, same tool table, even the same stock as you see there. But it does have the new name. Now, what we'll do is first, we'll change the post. So double click on cam part. And let's change it to a 5-axis post. And I think we've got one of the basic ones that come with the software, the HOS 5x. Now, when you change post, even if it's not from 3-axis to 5-axis, you're always going to get this message here saying you're basically changing the references of everything. This post is going to have some different functionality. So do you want to save a copy of your original one when you're working on this copy, or do you want to just do continue? Now, this is a copy of that original file, so I'm okay to say continue. I'm just going to change this post in this one file, and then the 3-axis one stayed the same, so we don't have to worry about that. And then it just shows you what's different. I'll just say okay, and there we go. Now, when you change the post, remember that there's two files there. There's the GPP and the VMID, and the VMID is the definition of the limits of your machine. So if we're working on a completely different machine, you might need to change your iMachining definitions. So keep that in mind as well. But in this case, we're not using iMachining. So save as, and if I want to keep the same work done by the 3-axis operations there, but I don't want to actually have to repost them every time, what I can do is I can suppress them. But remember from what we said last week, when you suppress something, you're actually removing it from consideration. So if we still want to update the stock, we just don't want to G-code it. There's actually, right below suppress is something that says suppress G-code. And essentially, if you take a look at it, you get these boxes around your toolpaths there. I can't actually G-code them. G-code is grayed out, but it does still update the stock. So I can still see the updated stock there. So this is almost like, this is stage 2 in the part production life. It was on a 3-axis machine. We're bringing over that stock. We're bringing over these toolpaths. We're just not doing them over again. This is another way to retain that stock definition from when you go from one machine to another. And then from there, you can add your 5-axis toolpaths. You can see they're all open up now that I've chosen a 5-axis post. But let's say I wasn't ready to do that, or I've made it something on the part and I don't want to save it. There is actually a way to close out of the file without saving. You can basically right-click, and instead of just close, added now, and I believe it's 2020, is close without save. So close without save is still a way to properly close the file. It's not going to get stuck in the temporary folder like you usually do when you click the X in the top right corner, but it is a way to close it without saving the most recent change. And that's actually new in 2020.
Yeah, and this allows you, you know, anytime you guys close out of a part, you save and calculate something, everything is getting written to that temporary folder. And now if you do have a whoops in there, now instead of going into your task manager and killing the program so it doesn't save, you do it that exact way that Mark was just showing you guys.
Yep. Now it's still saving up to the point of when you open up the file. So it's not like you can save at a certain point and then close and not save the most recent change. It is, and correct me if I'm wrong, Kevin, but I think it's basically you're closing it properly without saving, but it only saves to the point that before you opened it up.
Correct.
Right?
Yep.
Yeah, so there's still that drawback of the whole temporary folder versus compressed folder issue, but at least this way you're not crashing it, you're not causing it to stay stuck in the temporary folder, which can lead to issues. Okay, so there's a question from Brian. What about the tool table? Well, this is a copy of that file that we saw on 3-axis, and you can see it brought in the same tool table. So it is just a pure copy. So I can add my tools on top of that. I don't want to get rid of these tools because, for one, I actually can't. They're being used in those toolpaths. Even though the G code is suppressed, they're still technically assigned to those toolpaths, so they can't be deleted. But they are, they're not useful to me now, or maybe I loaded the same tools in the 5-axis machine and these same tool definitions can be used, in which case I can leave them on screen because I'll probably be using them. But the tool table is the exact same one. Everything from that previous file, the 3-axis file, has been copied into the 5-axis file. Okay, one of the other questions that was left over was, what is synchronize and what is break associativity? And I think that question was relating to this submenu here. So you have check synchronization, synchronize and calculate, and break associativity. Real simple, this is the idea that every toolpath you program is tied into a piece of geometry, and that piece of geometry is tied into an ID number or some sort of identification from SOLIDWORKS. So the way the associativity works is in the original part file you got from SOLIDWORKS, every face, every edge has an ID number. And that ID number is what we refer to when we select the geometries inside SolidCAM. So if there's a change on the SOLIDWORKS side, that change gets incorporated into the SolidCAM side of things, into your CAM part model, and then your toolpath will update to the new version of that geometry. It's a larger hole or it's a different hole location, whatever the change was. So that's associativity. Let's say, though, that this is a Rev 1, and now you have a Rev 2, but you don't want to overwrite your Rev 1. Well, just like we saw with the Save As, you can make a Save As version of your file, and then in that Save As version, click on Break Associativity. That way, all the toolpaths, all the geometry, the design model itself has now broken associativity. It will now not update versus the new version of the file in SOLIDWORKS. So it's the opposite of what you're trying to do with some of this integration. You've got a Rev 1, you don't want it to update, you want it to stay Rev 1 forever. Click on Break Associativity, and that toolpath will never update when it sees an update on the SolidWorks side. It actually won't even bother to check anymore. Is that about right, Kevin?
Yep, exactly.
Now, synchronize is when you want it to do that. So check synchronization is basically you're telling SolidCAM, you're forcing SolidCAM to look at the original geometry that is selected and then confirm that it's up to date. And then if it is up to date, you can tell it to just resynchronize. Actually, basically this one will check, and then this one actually does the synchronization. It updates itself. And then because it just updates itself to the new version of the geometry, you're probably going to want it to calculate. So that's what this third one is. You can just click on this one straight away and get it to check, bring itself up to date, and calculate the toolpath. Whereas if you just click on this one, it just updates the geometry selection.
And since we're kind of on the check synchronization and synchronize, you can also do this with your target and your stock models as well. You can do a check synchronization and synchronize too. So in the happenstance, or depends on how you have your settings, if you guys have your synchronization settings to user demand, and Mark goes and makes a change in here, we basically want to go and just do a check synchronization real quick. And the check synchronization on user demand most of the time will pop up with the stoplights on the stock or the target or the operation that needs to be synchronized on. So it's just letting you know that by doing synchronization on user demand, it's telling you what has changed. But in a very rare instance, they may not pop up for your stock and your target if you make a change. And that's only if you're making the change inside of the SolidCAM model itself. So if Mark went into the SolidWorks tab and made a change to the model instead of just SolidWorks alone, sometimes it just takes a little bit longer to synchronize that, where if he made a change and Mark wanted to see that change instantly and he wanted to update his target and his stock to go with that new change, he can come up to the top and do check synchronization and do the synchronize right there as well. And if anything is out of sync, it will pop up with the stoplight, or the, I guess it's not really a stoplight, but it's a red-green. You want to show them that icon at the top, Mark? The SolidWorks stop.
Oh yeah, it looks like that.
It will look just like that for you.
It's the same icon, but it'll be overlapping your icons over here. So any one of these toolpaths that it has geometry that needs to be resynchronized, or if your stock and target need to be resynchronized, it's a very similar symbol to this. It just overlaps that symbol there. And very similar to what we talked about last week, Kevin was talking about if you hit this plus sign, it actually shows you what needs to be resynchronized. So let's say in this HSS toolpath, it was only whatever faces were selected under faces 2 that need to be resynchronized. With this collapse like this, I would see the stoplight symbol right next to that HSS symbol. But if I click on the plus sign, I would see the HSS, faces selection there with the stoplight symbol indicating that that's the thing that needs to be resynchronized. And when you expand it, you can right click on it and do the check synchronization and synchronize as well. So you might not need to recalculate the entire toolpath. You might not need to resynchronize everything. You might just need to resynchronize the one thing that needed to be resynchronized.
And since we're kind of still in that synchronization stage, you know, we get the question asked on support line is, well, if I get a rev change, how do I handle my rev changes? Well, usually on a rev change, not too often, they're just going to send you the exact same model with the exact same name. And so usually what they'll have is they'll have Rev A, Rev B, Rev C, or Rev 1, 2, and 3. So there's no right way or wrong way to do this. So what Mark can do is he can right click on CAM part and change model reference to that new rev. But what I did at my previous job is I would do what Mark did, what we kind of started talking about here. I would do a save as first and then rename it to that Rev 1 and then change that model reference. Just in case, you know, you ever had to go back to that original rev, you still have all the data, everything that you need right there as a fallback, where if you update to Rev 2 or Rev 3 with the change model reference, you just lost your original rev in there, and there's no way to go back and get it unless you go back through and reprogram it. And I've been burned a few times by engineers that, oh, well, no, we like that original rev, we're gonna go with that one. Then you're having to go back through and refine that original rev, and it just makes it more work. So you will have more files. So if you have 5 revs in one part, you're going to have 5 different SolidCAM files, but you always have that assurance that you always have that original and all the backups there for you, if that makes sense.
Yep, absolutely. Yeah, it's basically just revision control, depending on how your company runs it. But I had a similar situation Kevin's describing where we had been running the new product model. It wasn't necessarily Rev 2, but it was just the new version of it on, I used to do indexable tooling, and the back end was a certain type, and then they changed it for whatever reason, so it has a different contour or whatnot. And then we ran that for production for about a year, and then we got complaints. They didn't like it, the customer base. So we went back to technically a Rev 1, but it had been a year, and we didn't keep the models or anything like that, so we had to basically make a Rev 3 that was the recreation of Rev 1. But if we had kept everything like Kevin had said, we could have just pulled the old programs and then run them again and then reproduced what was understood to be a Rev 1. So revision control is more of a customer company kind of related consideration, but anything you try to do to keep that revision control, you have the ability inside SolidCAM to do that. So either make multiple copies, or even if you think about it, maybe even the configurations we talked about last week, you can make configuration versions of each revision. And then remember, when you toggle between your configurations, you can recalculate and repost the code. So there's another way to do that as well.
Yep.
Okay, so any questions on this or any new questions? Frank, I noticed that you're in attendance. I got your email, and I think to answer your question, I want to do a whole session on it, because I think I want to give you the full fleshed out discussion on what you're talking about. But any other questions for today? If there's no questions, does anyone get my reference about Kevin?
I don't.
You don't? Yeah, I know you don't, because you're not a movie guy, but that was from a movie. Let's see, if nobody answers, I'm going to give you some hints. It's a movie from, I believe, the early 80s, maybe? Nobody knows? One man, one machine, all cop? Or part man, part machine, all cop. That's why I screwed up. Yeah.
Oh, is that RoboCop then?
That's RoboCop, the future of law enforcement. Ah, Jake knows it. Good. Jake, he knows RoboCop. Cool. Okay. So let's see. If we don't get any other questions, I guess I will jump into Frank's part. It's actually a question that I've gotten a couple of times, and once you see the answer, Frank, I think you're gonna think maybe it's gonna be one of those things where why didn't you think about it? But so basically, Frank's question is he's got a cylinder with a flat on it. And because of some of the things that SolidCAM does, some of the things that are just kind of generic for CAM programming in general, there was something that was overcutting or something like that on his part. Basically, he's got a part that's probably not this one, but it's very similar to the fact that it's basically just a square shape or a couple of flats or even a hex on a cylinder or a bar stock. And if you use face mill, or not face mill, but the facing operation, remember that facing considers whatever surface you click on as the top face of the part. Basically, it's open on all sides. It's almost like a pocket that's open on all sides. So if you use the facing operation, it's going to think that you want to machine all that stock. And that's why it's crashing into the back there. So I would not use face. I would not even use face if you don't even have a back end, but you don't want to cross this back line here, because again, facing considers all edges to be open. That's why there isn't really an option to set an open edge versus a closed edge inside facing. So what you would do with this is you can use either the profile operation, the pocketing operation, or there is actually a toolbox cycle specific to flat on a cylinder. So let's go through each one and see how you can use it. So in terms of the profile operation, what I've chosen is just that back line. Now that back line on this part just happens to be right on the edges of that cylinder, but it could also be the flat on a hex that is a little more inside the cylinder. It really doesn't matter, because in the profile toolpath, you have the ability to do extensions. So if this thing was not right at the edge of the stock and I should have extended it a little bit more, always remember that you can actually do an extension inside of this window here. And that can be found in the technology section, geometry button. So you have the ability to do an extension if you like. But in this case, this chain is right on the edges, so I don't have to do any extensions. The tool, in this case, I've chosen a 1/2" end mill. Levels, because of the stock recognition, or even just if I just chose it, I can do top of target, top of stock, and then the same with this one. I actually clicked on that top face and got that associativity. So again, a level of associativity just by clicking on the geometry. If I wanted to basically break associativity, I could just type in the number. But it basically means the same thing in this file. It's just that the associativity would follow that face. So if I change the shape of the square or the shape of my stock or anything like that, the associativity will follow that face, versus if I put that number in there, it'll always go to, in this case, 290 thou below whatever I've chosen as my upper level. So that's just another level of associativity there. But basically what I'm showing you here is in the profile toolpath, you have the ability to go from the top of stock or top of target down to whatever face. Now what happens with this though is if you've used profile before, you know the tool is just going to follow that back line there. It's not actually going to do all this material. And that's because profile is mainly I usually refer to it as like a router toolpath. It just follows whatever path you tell it to follow. But in this case, the tool is not large enough and I need to actually do all this material. So how do we get it to do that? Well, in the technology section, in the lower right corner, there's something called clear offset. And what this basically is, if I put my mouse in here, if you look in that bottom left corner there, this is actually how much material we need to travel across. So even though profile by default is some sort of router style toolpath, you still have the ability to give it a radial step over. And that's what this is basically right here. This is the amount of material I need to travel across. So to set that, I chose offset and I chose this face. It's recording these coordinates, but really what it's doing is finding the distance between my chain and that point. So that's the 2 inches that this thing is, right? And then here's my step over. So similar to what you do in pocketing or similar to what you do in HSS, anytime you have a step over, a radial step over, that's this value here, and then this is the travel across there. So there's nothing associative about this. There's nothing pocketing related about this. This is simply, here's how much material I have to travel across, and here's the steps across it. And what that does is it generates a toolpath that looks like this. So it's still a profile toolpath. It's going to do one path, retract, reposition to do the next path because I told it to do it one way. But you can see I've got my depths of cut. Let me just get a front view of this thing. I've got my depths of cut and I've got my step overs, and that does all of that. And because I chose this back wall, this line here as my wall, it's going to go up to that point and that's it. So I don't have to worry about colliding or over traveling or anything like that. So that's one way to do it. The drawback of that though is you can see that it's not paying attention to the fact that there's curvature there. So it's actually trimming, cutting the air over here because that curvature means there's not that much material versus down there. So I want to trim that a little bit. So I'm going to jump right to the toolbox cycle because you program it exactly the same way. So if we take a look at my geometry is that back line. I got to that because I used flattened surface on a cylinder, which is one of the toolbox cycles. My tool is the same, my levels exactly the same, top of target down to that face. In the technology section, for a flat on a cylinder, I'm doing the exact same thing. I'm giving it my clear offset, how much I'd like to step over. I'm giving it my step down. It's going to generate it very similar to a profile toolpath, but in this case, I can tell it to go along or across, depending on how I'd like to go across that surface. Wall offset, floor offset, extension, because it kind of imagines I probably want to go off the cylinder a little bit. This is where you can actually do that extension very similar to what we saw in profile. I can tell it to go a little off the sides if I need to, because maybe that one line doesn't represent the entire flat. But very similar to, dissimilar from that is the fact that it's now can recognize that it's on a cylinder. So I can actually give it the diameter of that cylinder. So it'll recognize for my levels where on the cylinder this thing is sitting, so that when I take it from the front view, it actually trims it a little bit. I'm not sure if you can see that there. How do you get to the toolbox cycles? If you right click and go to add milling operation, toolbox cycles is right there. If you go from your menus up here, I believe it is it 2.5D? Yep, so toolbox cycles. If you go to 2.5D tab, it is over here. So it's just another one of the operations in the list. But basically, the toolbox cycles are bare bones versions of Pocket and Profile. So you'll get it for certain features. If we just open up this toolbox cycle once again, anything that is very similar to what you see in these images, you can kind of do a very bare bones, very minimal parameter selection for some of these. And a lot of these are very unique, but the flat on cylinder is one that I find a lot of people who don't have a 3D toolpath will use, because this is a really great way to get a trimmed, almost 3D-like toolpath when you don't even have the 3D package.
Yeah, and there's a lot of very powerful tools in there too, and maybe sometime we can go over all those toolbox cycles, because like Frank and probably a lot of you guys in here, you guys have never seen the toolbox cycles before. So a lot of powerful tools in there that really simplifies things for you.
Well, I would say if they've been watching the videos, they will have seen Toolbox Cycles, because
Yeah.
there's been at least 2 or 3 Kev cams on there. So
Yep.
definitely it's something that has been seen. Okay, and then if you don't use Profile, you don't use Toolbox Cycles, you can still use Pocket as well. Because again, if you consider this to be a pocket that's open on all 3 sides, when I click New, I can use my smart face. I can click on that face there, and it gives me a pocket that has 1 wall and 3 sides. And then from there, you're doing the exact same thing. You're choosing your tool, your levels, your technology. In this case, I have it set to contour, open pocket, approach from outside. We get a toolpath that looks like this. If you want it to look almost the same as what we did with the profile, then I can switch this to hatch. I can get it to be, let's say, 90 degrees to the x-axis. And we can use profile style strategy. And then we get something that's exactly the same. Now, this versus just regular profile, the difference is I've defined the shape of my pocket. And there's actually a tip and trick video on YouTube channel for this as well. If I didn't have a nice clear offset where the chain was the same on both ends, if I had maybe some sort of triangular shape or anything like that, then the pocket toolpath using the profile style actually trims the toolpath in this direction. So if we had a unique shape like this, the pocket would dictate the travel of the tool as well. So it would actually trim it in the XY plane. But with pocketing, you get the same issue as we had with profile. It's not trimming it to the curvature of the cylinder.
Now, we could take it one step even further, since we were just talking about this on Friday, is in HSS, the stock definition as well. You could set it up as an HSS operation.
We could do that as well, yeah. Now, HSS, I wouldn't usually use it for roughing like we talked about on Friday, but Kevin's right. We could do the exact same thing. So let's say we do parallel cuts linear. As my drive surface, it's that guy right there. I always set this to this option here so we can use the tool as much as possible on that surface. The value from X is also 90 degrees. If we're doing this as roughing, we can leave some material on that face as well. Go to Tool, select the same tool. Levels, we can set it to automatic, or we can just leave it as plain. Again, this is just the clearance plane. Toolpath parameters, we're using a flat end mill and we're doing it on a flat surface, so my step over can be exactly what I want to step with. We can do one way as well, just to make it very similar to the profile. We'll do it as one way. Tool control, nothing really here to control. Links, same as before, we can retract to the clearance area. We're going to make this look almost exactly the same as the profile. The only thing you'll have to do different here is, now that I've told it I want to machine this surface and I've told it I want to take the tool right to the edges, it actually is going to go right to the edges. So if it collides with this wall, I need to account for that. So in the gouge check, I'll just include that. I'll say, check the tool tip and the tool shaft, trim the tool path in the case of a collision, and my check surface will be that surface right there. So it still considers this to be a wall. I just have to actually choose it as that wall. But we'll get a tool path that looks almost the same, except that in this case, it's not starting from the outermost point and going towards my edge, it's starting from there. But if I don't like that, I can always go to flip step over. And now it starts from that side.
And then you can,
if I need my depth of cut.
Yeah, you can do roughing in more and this toolpath should look identical to the Toolbox Cycles, but this is a great point to kind of show right now is look at all the input that Mark is having to put in to get this to adapt to the cylinder stock, where that's why the Toolbox Cycles is a very powerful operation, and it's right in the 2D, and all Mark had to do was click on the face, click on or tell it what size diameter, and it automatically adjusted for it that way as well.
So I'm going to put a lot more steps or tinier steps in here just so we can see the curvature of the toolpath. So let's say we put in 10 steps of 30 thou, just so we can see a lot of lines of code and we can see the curvature. But you can see that the curvature ends right there because there's no material to be removed. So the stock definition trimmed the toolpath at that point. Okay, so I guess we covered all of Frank's question. So if you have any other questions for tomorrow, for the rest of the week, if you have any suggestions for a better intro for Kevin, I'll give you my email.
We don't need a better intro.
No, well, I got a whole list, so you guys are going to go after my list. I got about, I think I got like 10 for the next 2 weeks. But if you have any new ones, I'm giving you my email in the chat section.
Oh, here, I'll be nice, Mark. I already pre-did it for you, so you can celebrate.
Yes, because I cannot talk and type at the same time. So there's my email. And you also have Kevin's email from the CavCam videos as well. If you have any questions, any comments, you can always email us. If you're looking for direct training, I know some questions that I've been getting are relating to you can't attend some of the webinars, you can't attend the SolidCam Live. Always remember that if you have online training hours as part of your purchase, your last purchase, your update, whatever it is, or even if you don't and you'd like to get some, contact your local sales guy and then they can quote you some hours and you can do direct training with myself, with Kevin, with anyone on the SolidCam team. All of us are experts in one field or the other, or all the fields in the case of Kevin. We can do training with you directly in a GoToMeeting, and it's live as well. So using a phone or mic and speakers on your computer, we can talk directly, get your questions live. Also, remember that we rely on word of mouth for most of our marketing. So if you know anyone that could benefit from SolidCam, or always remember we have many products, SolidCam, InventorCam, iMachining for NX. If anyone could benefit from those, let us know. Put them in contact with us, and there is a finder's fee associated with them getting into a demo, getting into purchase, however we can help them out. We'd like to, obviously. But like I said, we'll be continuing this until at least May 15th. So the same login you used today should get you into all the sessions up until that day. And if not, we probably even will extend it using the same login. I'm not sure, we'll have to check, but that'll end today's session. So we'll talk to you guys tomorrow at 2 p.m. Eastern time. Stay safe, keep your family safe, and we'll talk to you tomorrow. Have a good day.
All right, thanks guys.